2.6 problem 24. This is maybe the first example in this section of homework here of kind of a category of problems that I don't think any one of you should beat yourself up here if you looked at this and you were not able to figure out how to do this problem on your own. I didn't put anything like this in the notes either. However, my hope would be that now that we go through it, you guys are going to look at it and say, oh, okay, now I see what they did there and that makes some sense. And then hopefully you'll kind of keep that in the mental arsenal here moving forward. First thing you ought to try with a limit right here, of course, is plug and chug. But here you go. If you were to take the cosine of 0 radians, you end up with 1. So the numerator becomes 1 minus 1, which is 0. And down on the bottom, the sine of 0 radians is 0 as well. And 0 over 0 is undefined. And it's probably the most common thing that happens when we're trying to do a limit here. So we shouldn't be surprised by that fact. Okay, what we're going to do instead, though, guys, is utilize the fact that this numerator here, 1 minus cosine of x, can be manipulated in a way that isn't all that difficult to make something nice. I don't want to give it away. I guess I am going to give it away. Here we go. We are going to multiply here, guys, the top and the bottom of this fraction by the conjugate of that numerator. And the conjugate of the numerator would be 1 plus cosine of theta. Do it to the top if you want, but then you have to do it to the bottom as well. So what have we accomplished here, guys? That now equals the limit as theta approaches 0 of, well, up in the numerator, 1 minus cosine of theta times 1 plus cosine of theta. Multiplying two conjugate binomials gets you a difference of squares. The 1 times 1 is 1. The outer and the inner products are going to cancel each other out. And then at the end, we're going to be left with a minus cosine squared of theta. That's just the first and the last product in FOIL. Outside and inside cancel each other out. Now the denominator, nothing pretty happens. So I'm going to leave that one in factored form of sine of theta times the binomial 1 plus cosine of theta. And maybe you see what happens next and maybe you don't, guys, but here we go. This is now going to become a limit as theta approaches 0 of, all right, guys, that numerator is something kind of special. Let me go to green here off to the side. What I'm hoping everybody remembers, your basic Pythagorean trig identity, sine squared of any angle, theta, plus cosine squared of the same angle is always equal to 1. And therefore, if we brought this cosine to the other side, we would get this fact. Sine squared of theta is equal to 1 minus cosine squared of theta. That is what our numerator currently is. We're going to turn it into that. So 1 minus cosine squared of theta becomes sine squared of theta. And in the denominator, we keep it as sine of theta times 1 plus cosine of theta, but I'm hoping now we see what's actually happening here, guys. Now, the sine of theta on the bottom cancels with one of the sine thetas on the top. So now we just end up with sine of theta in the numerator and then 1 plus cosine of theta in the denominator. And I believe we now should be able to evaluate this. So I'm not putting the limit now because I'm actually going to let theta become 0. Up in the numerator, sine of 0 is 0. And down in the denominator, that's a 1 plus, and the cosine of 0 is 1, which of course is 0 over 2, and that gets us our final answer of 0. So this little trick here, guys, of multiplying by the conjugate, I think this is the first example we've seen it, but as I'm looking at the rest of the homework, that might show up a time or two in the future. So keep that trick in your back pocket, guys. When you see the 1 minus cosine of theta, you can turn it into 1 minus cosine squared, which eventually turns into sine squared and canceled with the sine on the bottom. So a nice little trick to remember for the future.